maybe a voice to let me know you can see it.
Yes.
Okay, great.
Yeah.
Well, again, so thank you so much for being here, and particularly to Stella for connecting me to this community. We're new, my wife and I, to Nova Scotia, and we knew we didn't know very many people at all. So having some community here via family was really important, and this is just another step for us in terms of building community. So I hope to remain connected with you folks moving forward. I was told that I would have about 25 minutes to talk. So I chose 4 stories that sort of chronicle my 25-year history in biodiversity conservation and environmental protection. They're linked. These stories are quite linked in terms of the story we just heard, in terms of everything being important and the interconnectivity of nature. But as well, the stories sort of follow my journey, but also build upon my own understanding of biodiversity and nature, and how important it is to our own survival. Some of these stories might be a bit funny as well, and certainly feel free to. I'm a big fan when I do lectures in person. I'm a big fan of audience participation. So if you have a question or you wanted to say something, certainly unmute yourself and say whatever you need to say. It won't take me off guard. I can certainly stop and we could talk about it. But hopefully at the end there's some time for questions too. So the 4 quick stories, there they are. Leeches love frog eggs, roadlessness, can whale poo save our planet, and then alien invaders of Guestwick. And we see how we do here. So I was born in central Ontario. I was born in Huntsville, Ontario, and I lived my first sort of 18 years there. And I primarily found refuge in Algonquin Park. It was my first job as a canoe trip packer. I would pack people's tents and food for them, and eventually became a canoe trip guide, and became quite versed with Algonquin Park. And it was sort of my exposure to nature. I found solace in the park. I did many solo canoe trips there. I took German tourists and young campers from the many camps in the park out on guided trips. And what that experience in Algonquin sort of told me or allowed me to see for myself was that nature and nature conservation and nature storytelling was certainly going to be my life. I knew somehow, I didn't know how at that point, but at some point, on a canoe trip, it dawned on me that I needed to figure out how to become a professional biologist. So I did. I came out east, actually. I went to New Brunswick. I went to Mount Allison University and did my undergraduate degree in biology. Pretty lost at the time, did a minor in chemistry, kind of flew through it. I spent more time, I think, in Halifax in bars. Maybe I shouldn't say this, but I spent a lot of time out off campus. I didn't do extremely well in my first couple of years because it was so new, I could be away from home. The reason I chose Mount Allison was because it was more than 2,000 kilometers away from my parents. And I love being there. But eventually, in my final semesters, I honed in on a few professors and biology and ecology particularly, and it was amazing. And then I took a hiatus. I actually broke away from my love for nature and frogs and salamanders and toads, and I traveled the world for 5 years or so. My computer is frozen here. Interesting. There we go. Anyway, long story short, I did spend about 5 years funding world travel through tree planting. I traveled to over 30 countries, spent months at a time in isolation on islands, thinking about life and surfing. And then I would come back to Ontario or Alberta and plant trees again, buy another plane ticket and do it all again. Anyway, I was sitting on a sand dune in the middle of Namibia in southern Africa, and I had this undergraduate degree. I knew I loved nature. I knew I loved frogs and toads and salamanders and biology. And so I thought I got to go home. So I went back to Ontario, went to Peterborough, and I did a master's degree in ecology on these critters here, salamanders and frogs, these animals you've been seeing. And it opened a whole new world for me. I thought, this is it. I love academia. I started publishing papers, and I started, building relationships with professors and going down this wonderful rabbit hole of frogs and toads and salamanders, their natural history, their conservation. And this is a picture of me. I'd set up a huge study site in near Buckhorn, Ontario, on these little salamander larvae where they'd lay their eggs out in the forest, and I'd have plots and little boards and watch them go between the ephemeral wetlands and back to the boards and studied them. And eventually I finished my master's degree and started a PhD with a wonderful man at Trent University. I was 2 or 3 experiments into the PhD. And I got very interested in the larval stages of these amphibians. So the eggs and the tadpoles and the salamander larvae. I was fascinated by their metamorphosis and the change. And this is a picture of a bullfrog tadpole under ice, swimming around. I just felt that these were, incredible animals. So I kept going down this rabbit hole, and then finally I published a paper one year, 2007, with this title. If you can say that 3 times fast, I'll give you $100. But basically, this was an epiphany moment for me. I published this paper that I was so proud of: phenotypically plastic responses of ranoclimatin embryos to conflicting predation risk. And I thought, everybody was reading this paper. I thought I'd be on the cover of the New York Times, and it just didn't happen. People, I realized then that I was in this niche, esoteric rabbit hole of academia, and I was speaking to myself and maybe a few other people in the world, which is important. And I have a whole other lecture on this. I'd be proud to give another time about the power of research and the need for research. But at that moment in 2006, 2007, I said, not for me. I can't do this anymore. I need to tell stories. I need to work with scientists, and I need to save nature. I need to conserve nature. So I moved away from, and the story very quickly, leeches, if you can follow me very quickly here. So frog eggs are very phenotypically plastic. They can sense their environment as an embryo. So I put frog eggs in Tupperware with different predators, leeches and dragonfly larvae and other things. And I measured their response, how quickly they were reacting to just the olfactory presence of these predators. And it was incredible. We published this paper, we published a couple others, but the idea was what we were trying to prove or show was that if a frog is a frog egg is in presence of a predator that likes to eat tadpoles, they will delay their development and hatch bigger so that they can be more responsive and adapted to that tadpole predator. But if they're in the presence of a predator that likes to eat eggs, like a leech, for example, they will speed up their development. They'll get out of that egg stage quicker so that they can avoid that predator. Anyway, I realized at that point that I needed to do something different. So we were living up near Algonquin Park at the time. I had a job as a biologist. We thought we had 2 little kids, and I thought, oh, this is the cat's meow. And this would be the job for the future for me. But they were paying me like $15 an hour at the time. And I had a lot of education. And so I said, my wife and I both decided that we would bite the bullet and move to Toronto, which was the big bad city to us local yokels from up in cottage country. We didn't know too much about Toronto per se, but we did. We bought a house right downtown. We made our home, and I got a job at the Toronto Zoo. It was the first time they'd ever hired someone like me. So they had some curators of natural history, and then they had all of the people that put the animals on display and take the care of the animals and do the education stuff, but they never had somebody on staff who was bridging those two worlds. You might not know this, but at the Toronto Zoo, for example, a wonderful accredited zoo, they've got, a half a dozen, PhD curators back of house that do incredible research on endangered species. They're doing some remarkable things to bring species back from extinction. And yet those stories weren't being told in the front. So they hired me to bridge that gap. And I spent 5 years there and did a variety of programs, from bringing business leaders in and showing key, CEO executives all about the zoo and recycling cell phones and connecting that to gorillas in Africa. We did this huge project where we took the manure from our elephants and our rhinoceroses and we put it into a biodigester to create energy. And it was really remarkable. But the one I wanted to quickly talk about with you guys today was this program we started at the time called the Ontario Road Ecology Group. This is a bad map, but if you're from Ontario, you'll know that's Algonquin Park. The reason it's a bad map is because you can't get a good map of this particular story. What this map is telling the viewer, and it's done by a master's student, a friend of mine back then, is that that red line is the big road through Algonquin Park. That's Highway 60. That's really the only road that people think goes through Algonquin Park. They think it's a protected space and they think the rest of the park is wilderness, when in fact there's more roads per density per square kilometer than anywhere else in Ontario. There are more logging roads in Algonquin Park than there are roads in and around Muskoka itself. So this fact blew me away, and I knew that there was a lot of mortality of animals. I knew that roads were impacting biodiversity, but we didn't know at the time what we could do about it. So we began and we started this amazing group called the Ontario Road Ecology Group, which was the only kind of group of scientists and educators of its kind in the world at the time. And what we did was we brought about 1,000 scientists, road developers, transportation planners, politicians, educators, religious leaders. We brought them all into one umbrella and we built this sort of virtual team before virtual teams were a thing, to sort of get at what we could do to limit the impact of roads on biodiversity. And, there's many stories I'd like to tell, but one, just on the left there, this is a schematic map of the proposed 400 series highways in the GTA. At the time, this is 2011, I think, we built a model, Kerry Gunson and Fred Schuler and I, we built a sort of a predictive model that would help planners understand where the hot spots were. If you built a road through a wetland, likely you're going to be encountering more biodiversity than if you built a road through an agricultural field. So we did this incredible model. We applied it to these proposed 400 series highways, and we changed the way the GTA was planned. In fact, one highway I've just so pleased recently, it just happened a couple weeks ago, after 10 years of advocacy, has been stopped. And this is the road, the big 413 that was supposed to go from the main sort of urban area of Toronto over to Guelph and Brampton. Another aspect of this project, which ties into the title of roadlessness, and this is sort of where I'll segue out, is we need more wild spaces without roads. Roads, they're the biggest single human artifact on Earth. From space, you can see them. They are so pervasive. And when you get a road into a wild area, it allows for so much else to happen. That's how miners get in. That's how foresters get in. That's how developers get in. But if you can limit the amount of roads in the first place, it is the biggest and single strongest step towards protecting wild spaces. And so these are a few of the projects I've worked on over the years. I sat on the boards of the Yellowstone to Yukon initiative and the Algonquin to Adirondacks initiative. And then the one on the far right, I'm just getting involved with now because it's so true to my geography, is the Chignecto Isthmus between New Brunswick and Nova Scotia. These are places where we need to maintain wild spaces to allow the movement of animals through their normal migratory patterns. And so, just as an example of how the road ecology project that we started back in 2007 has actually manifested itself in my life now in 2021. And I'll just close with the most, positive story I can think of on this whole initiative. And this is a good point I'd like to make, is that I'm a big fan of not preaching the doom and gloom. So I'm a big fan of talking about positive stories, and this is a great one. There was the population of an endangered salamander called the Jefferson salamander near Brampton area, Burlington in southern Ontario. We knew it was there in 2005, 2006, and we knew they were getting killed en masse. These critters, these ambistomid salamanders, are underneath the ground for 11 months a year. They're mole salamanders. They live in the dirt. You rarely see them, but for one month a year, for a couple weeks a year, they come out en masse and they move from the forest to the wetlands to breed. And often these wetlands are on the other side of a road. So when they move en masse, they get slaughtered. And we were witnessing this. And so we brought this forth to the town of Burlington and the city of Brampton and said, hey, is there anything we can do? And they said, well, what could we possibly do? We can't close the road down. And we were like, well, why couldn't we? Let's close the road. And it was the biggest political battle of my young career at the time. We went to city council, we went to the provincial legislature, and we said, let's close the road just for 3 weeks. And we'll put volunteers on either side of it to calm the commuters who are frustrated that their traffic is going to be 5 minutes longer because they got to go around. It was an important road. It was only about, 5 kilometers long. Long story short, in 2016 or 15, they closed the road for 3 weeks. Not a single salamander was killed and hasn't been killed on that road since. And the city of Burlington now claims this initiative as their own. They're so proud of the fact that their Jefferson salamander population is growing and that no more salamanders have been killed. And I think the Burlington group that does this would thank the Ontario Road Ecology Group for how we brought that to be. So now I'm going to shift gears a little bit to the story of the hour, as it were. So I was at the Toronto Zoo. I promised my wife 5 years in Toronto, and then we'll go. We'll go back to Huntsville. We'll go back to Algonquin Park, or we'll go somewhere where we can be closer to nature. But then the Royal Ontario Museum offered me a job that was, again, brand new, very much like the zoo's job. And they wanted the same thing. They wanted someone to help them tell their scientists' stories well. And so my wife and I had a long talk and we decided, let's do this. And so we spent was supposed to be 5 years, turned into 8 at the Royal Ontario Museum in downtown Toronto. And this is a different institution. The Toronto Zoo, they may have 6 or 7 curators in the back of house doing all this science and work and generating novel content. At the ROM, at the time, there was more than 60 curators. And this is just a snapshot of a few of the ones I worked with. The guy in the bottom, your bottom left, Jean-Bernard Caron, is the world authority on the Burgess Shale and is describing a new species to science every week. All extinct species, but brand new species. The woman in the top right, Kim, is basically one of the Canadian leads on the Mars mission right now, the rover that's on Mars. She is the sort of the brains behind some of the equipment being used there, and she's a geologist that studies Martian rocks. And the stories go on and on. I'll get into one example here. For example, Doug Curry, great friend of mine, a wonderful man, and a wonderful scientist, and a storied scientist at the Royal Ontario Museum. But he studies something that I'm not sure is too attractive. He studies black flies. And I can't see y'all right now, but if I could, I'd say, how many of you like black flies? And I bet you not too many hands would get raised. So here you have Doug Curry. He wrote a book, 1,000 pages long, the book on black flies in the world, doing all this remarkable research. But how do you tell that story? What do you do for Doug to make him interesting to the general public? So basically what we did with Doug is we turned him into a bit of a social media star at the time. And we basically allowed his work to be showcased in the museum during our what we called Friday Night Lives. So this is when we would open the museum up at night to you know, Gen Xers and millennials, and they could drink and be in the museum till 1 a.m. And we would put Doug out on the floor with a big jar of blood, a microscope, and some black flies. And I tell you, his research never got more interesting than it did during those Friday nights. People loved talking to Doug. And since then, he's really become a bit of a social media star. And in fact, all of the work we did to raise his profile with the public turned into a major blockbuster exhibition that we launched just as I was leaving the museum in 2017 called Bloodsuckers. I realized at the time there's 65 curators at the ROM, and I was one sort of person. And when I asked, you know, where's the production house, who's the people that are going to help us make videos and do all the social media and communicate these stories, they basically said, oh, do you mean Zach? Like literally, there was one guy in the back of the house somewhere with all this video equipment, and he did all the work, but he was overwhelmed. So very quickly, we realized that we needed more capacity. I'm really proud of this, but we built a program called the Environmental Visual Communication Program. It was a graduate level program that took students who had an undergrad degree in biology or geography or science or environmental stuff, but had an interest in storytelling, and it had an interest in new mechanisms for storytelling, social media, videography, photography, infographics. And we brought them into the museum, and we brought the best teachers from around Ontario, and we taught them over 8 months intensively how to be better storytellers for 2 reasons. One, to give them a marketable skill and increase capacity in society for this stuff, but 2, to tell our stories at the museum. And it was a remarkable success. And one of these students was key to the story I'm about to tell you around blue whales. And her name was Jackie Edwards, and we sent her into the field for this. So everything I'm about to tell you now, I kind of learned vicariously through a student of mine, which was really remarkable. So how many people remember the 9 blue whales that died off Newfoundland? I know there's one gentleman on the call today from Gander, but you know, I guess I'm not going to interact too much, but basically in 2014, an incredible thing happened. I don't know if you remember, but the Gulf of St. Lawrence, the Great Lakes were frozen that year. It was a horribly cold winter, and the ice levels in the Great Lakes was at 95%. Ontario and Erie were completely frozen over. Superior was completely frozen over. And so the ice thickness out in the Gulf of St. Lawrence was you know, unpredictable. And this is absolutely an effect of climate change. Normally, we have great data to show that the waters in the Gulf of St. Lawrence are getting warmer and warmer and warmer every year. And we also know that the ice accumulation is getting less and less and less every year. But 2014 was one of these anomalies where it just so happened that it froze really quickly. The blue whales that go to the Gulf of St. Lawrence to feed, they had become accustomed through the 70s and 80s to showing up a bit earlier. You know, they were showing up in, you know, mid-April, early April, late March. They wanted to get into the Gulf of St. Lawrence as soon as they could, because it is a buffet for the great whales. They have an amazing feast in the Gulf of St. Lawrence. But that year in 2014, the blue whales, you can imagine them all waiting out in the Atlantic Ocean, watching the ice. As soon as they found a gap, they moved in to get access to this food. 2014, the gap closed behind them, and there was a massacre. At least 9 blue whales died. At least 50 finback whales died. Hundreds of minke whales probably died. And it was not their fault. They had been watching the pattern that had been unfolding and were just doing what their natural history wanted them to do. And they got caught in a climate change hole. So one of these whales, 2 of these whales, landed on the shores of Newfoundland, very close to communities, Rocky Harbor and a few other small communities. This one here, right at I think Rocky Harbor, and it bloated. I don't know if you guys remember this story, but it was bloated for a few days, and it actually made it on a Saturday Night Live, NBC's big program, and they made a funny joke about it's going to explode, and this was the punchline. Of course, it didn't explode. It was just full of gas, and it deflated on its own. And we saw this as an opportunity. We saw this as an opportunity to send students into the field to sort of tell the story, what's going on there, and to send our curators into the field to collect the bones. We didn't have a blue whale in our collection at the museum. We have every other whale species in Canada, but we didn't have a blue whale. So we generated a lot of money through philanthropy very quickly, and we sent a fairly large team of about 8 people plus my 2 student communicators into the field to Newfoundland, and they documented the recovery of the bones of these whales. And I'm just going to show you some pictures of how that went down. They had to tow it from one of the towns to another town so that they could get access to it, and that the flock of seagulls following this procedure was incredible. And there's Burton Lim, who, believe it or not, is an expert in bats. He studies bats. And only really knows about bats and moles and little mammals. So this was his first time with a whale, and he loved it. He was in there full on. And then we brought the bones, we put the bones in trucks, and we brought the bones back to Trenton, Ontario, and buried them in manure for a year. And then after they came out of the manure, we brought them to, we have a sort of a private facility out near Trenton. You can see a T-Rex skull in the back, and we let them degrease, and some cleaning went involved. We collected all of the baleen from both whales. This is the blue whale does not have long baleen. This is the baleen of a bowhead whale, a small bowhead whale, and the baleen of a blue whale would be a third that size, so very small baleen. And this, I wonder if anyone can guess what this might be. There's our two of our staff sitting next to the heart of a blue whale. So we were the first museum in the world to actually take a real heart out and preserve it professionally, and put it on display. And it was interesting, actually, because the Sir David Attenborough, who should never be contradicted, came out with a quote in, I think, about 2011 or 2010, saying, you know, no one had ever seen a blue whale heart before, but he had extrapolated from humpback whales and fin whales and made the statement that a blue whale's artery, the main artery out of a blue whale heart, is so big that a person could swim through it. And this was a big blue whale, 100-foot long blue whale. And you can see you could basically fit your head in there, but you couldn't get your shoulders in. So we were so happy to tweet to David Attenborough, sorry, here's the truth. And he acknowledged us and said, finally, I know the truth. And so we got acknowledged from the guy. Anyway, the point of the story is that it was a remarkable exhibition. It was a remarkable experience. It was a remarkable moment for our students to document it. And we put a big display on, and it was well received. But the one question we had through this process was, you know, why should people care? Why should people care about the blue whale? And so when asking that question, it's actually hard, you know. A lot of people say, you know, they don't impact me. They're under the water. What purpose or role could they possibly play in my life? And so I was put in charge in terms of the exhibition of developing that story and finding out some hook, some way to capture the attention of the nation and make blue whales important to everyday people. So of course, where did we start? We started with corsetry and you know, the normal uses you might think of whale oil and this and that. And very quickly, I'm sure you all know this, but I'll quickly mention it. You know, the blue whale, this is a bit doom and gloom, so apologies, but the blue whale is probably the best example of the single biggest mass extinction event by humans, perhaps ever. You know, at the turn of the century, blue whales were way too big to kill. You couldn't shoot them. If you did shoot them, they would sink. So whalers just avoided them. And at the turn of the century, when the full-on whaling was happening, there were still probably 500,000, 600,000 blue whales in our oceans. But we figured out how to kill them. And we figured out how to keep them afloat by inflating their throat sacs so they wouldn't sink. And our boats got bigger, so we figured out a way to get them on board these boats. And all of a sudden, these whalers were saying, the biggest whale in the world, the biggest animal to ever live, bigger than any dinosaur, is now accessible to us as a resource. So between 1959, 1960, and 1965, we killed 99% of every blue whale on the planet. There might have been 2,000 of these animals left when the moratorium came in, and we as a society agreed this can't happen. We cannot see this thing go extinct. So thankfully, we reversed course. Blue whales are by and large recovering across the globe, but their population is still probably, you know, in the tens of thousands or less compared to the hundreds of thousands that they were. And here's the kicker. When they killed all these blue whales, you know, 350, 400,000 blue whales, there's no use for them. We had started using fossil fuels for our lighting instead of whale oil. Corsetry become a thing of the past, and boutique things. There was no need for them. So we killed all those whales principally and almost primarily for one purpose, and that was soap.
That was what?
So I'm gonna switch gears. That's the doom and gloom. That's the story. But I still had to figure out a way to make them important to people. Why should we continue to protect blue whales? And so where best to go than to the people in the Mingan Archipelago and the North Shore of Quebec, or the North Shore of the St. Lawrence in southern, in Quebec, Mingan, to talk with Richard Sears and the authority on blue whales. And so I spent about 4 weeks out on the ocean, listening, watching, learning about these blue whale scientists, asking the question day in, day out, why is it important we protect these things? Here's Christian firing an arrow into the back of a humpback whale to take some DNA from it. It doesn't hurt the whale at all. It feels like a mosquito bite, provides a bit of genetics for us. And then we can do a whole pile of, these guys do all sorts of things with this data. They understand its natural history. They understand its migratory patterns. They understand where it goes and why. And so these scientists are telling me over and over again, there's so much science here. There's so much we don't know about the blue whale. We need to protect it so that we can understand it. And I thought, okay, this is okay, but it's not going to, turn the dial on full-on support from a population who's overstimulated. Young people especially, can't find connections to nature. This might not be our hook. And then I saw it. I saw their poo, and it was huge. I mean, I'm talking, this plume is 60 meters long and 10 meters wide, and there's so much of it. These whales, when they eat, they go down 100, 200, 300, 400, 500 meters. Sperm whales go down 2,000 meters, and they eat and they eat and they eat. And then they're mammals, right? They got to come up to the surface. They got to breathe, and they got to poo. And they don't poo at depths. They poo at the surface. And this poo is a remarkable nutrient and resource in the pelagic zone in the ocean. The pelagic zone being that space where it's the open ocean. It's where you just see blue and you don't think there's anything alive. In fact, out in the pelagic zone, nutrients limit a lot of biodiversity and a lot of productivity. But one amazing resource is whale poo. And so in these plumes of whale poo at the surface, incredible, huge proliferations of phytoplankton emerge. And phytoplankton, believe it or not, produces more oxygen and sequesters more carbon dioxide than all of the forests on Earth, all of the plant life on Earth put together. So everything on land that produces oxygen for us, from trees to freshwater algae to plants, all of it combined doesn't come close to the sustaining life force that we all need that phytoplankton produce in the ocean. But phytoplankton can't grow without these limiting nutrients. Phytoplankton need whale poo. And so you can imagine back in 1800 when there was 500,000 blue whales and 4 million right whales and untold numbers of gray whales and humpback whales, all of these great whales out there, all of them doing the same thing, eating, pooping, sequestering carbon, producing carbon dioxide. It was stabilizing our climate. And I'm not even kidding. Like, I'm going to show you a slide in a second that we just caught up to this scientifically. If we could repopulate our planet with whales, it may be one of the biggest mitigation techniques for climate change that we could do. So how do we tell this story to the public? Well, if I can get my computer working here again, we brought it to them. This is a big jar of krill that we, because krill are the things they go to eat, the source of the nutrients and the reason their poo is so orange. And so we put the krill on display and showed the public the krill. And this is my favorite little display, real blue whale poo. You know, this exhibition had whale bones in it. It had all kinds of interactives. It had lots of things going on, but one of the most popular little places for the kids and for the public to go was to go see this whale poo. And of course they want to know why whale poo is there. So then they learned about the story and carbon dioxide and oxygen and climate change. And it was amazing. We got so much media attention, so much press, and we really helped. Oh, there's me dressed as a krill. We also had the krill suit out so people could dress up as a krill and pretend to be part of the cycle. But really, what it did was the Royal Ontario Museum was ahead of the curve at the time. We made the story come to life, and that drove the scientists to get more funding and produce more good results. And then a couple years later, in 2019, the International Monetary Fund recognized whales and their role as ecosystem engineers as so important to climate change. And of course, the United Nations Environment Program now places whales, especially blue whales and the great whales, as a symbol for where our climate was and where our climate could be. So that's why whale poo is so important. And, you know, I am running out of time, and I knew this would happen. So I don't have any slides on my last story, but I just wanted to quickly tell you all what I'm doing now. I work for Parks Canada now at Kejimkujik National Park and National Historic Site in the Seaside. I'm a project manager there, primarily in charge of biodiversity conservation projects and projects that are addressing invasive species. And so Gaspewick is the Mi'kmaq term for Southwest Nova Scotia, and in Gaspewick is a biodiversity hotspot. It's an incredible. It's one of 11 priority places in Canada to protect. But there are some invasive species in Keji and in Southwest Nova that are threatening its very functionality as an ecosystem. And I'll just very quickly tell you that the one I'm working on now is called Hemlock woolly adelgid. It's the tiny, almost microscopic little aphid-like insect that was brought to United States in Virginia in 1951. Took a couple decades to build up its population. Since then, it's moved up the eastern shoreboard and killed millions and millions of eastern hemlock trees. This little thing attaches its stylet to the new growth of the leaf, sucks out the energy. The tree, when it has 1 million of these insects on it, succumbs and dies within 3 to 5 years. There's no biocontrol. It was found in Nova Scotia in 2018, and it's all over Keji. It is in well over half of our stands, including many of our old growth stands. And our job, my primary job now, is to figure out a way to bring the Mi'kmaq, the provincial forestry authorities, our scientists, other scientists, and the public together to figure out a way to co-manage this situation. And so it's an exciting project, another bit of doom and gloom, but certainly fulfilling, and Parks is a wonderful, wonderful place to work. So listen, in sort of closing, just sort of, recap that my life has been rewarding, and biodiversity has certainly been fundamentally important to my growth. I feel as though I've been blessed with an opportunity to help Nova Scotia and help the Atlantic Canada build up their sort of mechanisms to protect nature and connect with people. So I'm proud to be here, and I was proud to talk to you all tonight. So thanks so much.
Oh.